Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 8 from the Solomon L C2 collection, which is now become the P2 paper in International A-Level Edexcel. And this is question number 5 for my end of topic worksheet on differentiation from P2, and this question here has been asked by one of my students for me to answer, so I'm going to go ahead and do so. It says find the coordinates of the points where C crosses the x-axis. So the curve C has the equation given 3 minus x to the power of a half minus 2x to the power of minus a half, and we know that x must be greater than 0, of course, otherwise it will be undefined. It says find the coordinates of the points where C crosses the x-axis. So we know that something crosses the x-axis when y is equal to 0. Okay, so if I take this equation and replace the y with 0, I have 3 minus x to the power of a half. Well, I'm going to write this as 2 over x to the power of a half, because we know that a to the power of minus m is the same as 1 over a to the power of m. Okay, and that 2 is not included in that power, so the 2 stays up there. That becomes x to the power of a half as a denominator, and that equals 0. Now the reason I did that is because I like to write it in this form so I can see that I have a denominator of x to the power of a half, and I want to get rid of this denominator in order to solve this equation. It just makes life easier. So what I'm going to do is I'm going to multiply both sides of this equation by x to the power of a half, which is the LCM of the denominators, in which case this becomes 3 times x to the power of a half minus, now you've got x to the power of a half multiplied by x to the power of minus x to the power of a half. You add the powers, so you get x to the power of 1. So that this is going to give me minus x, and then if I multiply 2 over x to the power of a half by x to the power of a half, they cancel, leaving you with the minus 2 equals 0. So this is a form of equation which I am able to solve in a way which is like this you could say is a hidden quadratic. All right, it's kind of like a hidden quadratic, you could say, right? Because I know that x is the square of x to the power of a half, so I could kind of like try to use quadratic equation type of solutions to solve this. So what I can do is I can say let x to the power of a half be something. I won't use x, I won't use y, I'll say, for example, u. Alright, so I can replace the x to the power of a half with u. Now, that means that x, if I square x to the power of a half, I'm going to get x. So this will be, x will be the same as u squared. So I can replace the x with u squared, the minus 2 as it is, and I've got like a quadratic equation. If I just multiply by minus 1 to write the u squared term as positive, I'll have a u squared minus 3u and plus 2 equals 0. And then I can factorize this. This will give me 2 factors with u at the front, both negative signs. 2 numbers multiplied to give me 2, and add to give you minus 3. Well, there must be minus 2 and minus 1. So I know that u is equal to 2, and also u is equal to 1. Those are the 2 solutions for u, but we want to find what x is. Now we know that x to the power of a half is equal to u. Okay. What we could say here, I mean, I could say x equals u squared, but you've just got to be a bit careful here, because sometimes if you get negative values for these, in this case it was no problem whatsoever, you have to be careful. So I wouldn't take this statement, because it might give us a false solution. So I'm going to take this statement here, x to the power of half equals u. Now what this means is, this means the positive square root of x is equal to u. So the positive square root of x is equal to 2, and the positive square root of x is equal to 1. Now that's perfectly viable. You can have the positive square root of something giving you a positive number, so that's fine. But if, for example, one of these was negative, like u equals minus 2, then this would mean the positive square root of x is equal to minus 2. Well, that doesn't make sense, because a positive square root of something can never be negative. And when you have a square root in a question given without knowing whether it's, without the plus or minus in front of it, it means it's referring only to the positive square root of that thing. So this refers to only the positive square root of x. Okay, so this is fine. There's no problem with this. So I can write this as x equals 4, because I've got to square both sides, and x equals 1. So we know that the coordinates of the points where it crosses the x-axis are 4, 0, and 1, 0. Of course, the y coordinates is 0. You could, if you want to make sure that you've got the right answer, by putting inside this equation 4. If I put 4 in this equation, okay, let's put it in this equation, you'll have 3 minus 2 minus 2 over 2. So 3 minus 2 minus 1 is 3 minus 2, which is 0. That satisfies the equation. And if I put 1 in here, I'll have 3 minus 1 minus 2. 2 over 1 is 2. It will also give me 0. So I know that I've got the right solutions. Those are the x values that make y 0. So those are the x values which lie on the x-axis, where y is 0. Okay, now for part B. Okay, I'll put it on the other page, I think. It says, find the exact coordinates of the stationary point of C. Now, the stationary point of a function is where its gradient function, dy dx, is equal to 0. So if I take this equation and I find dy dx, I have to multiply by the power. The 3 is dropped because the differential of a constant is 0. Multiply by the power, so it's a half times minus 1, which is minus a half. X to the power of, take 1 from the power, get minus a half. Then I have minus a half times plus 2, which is plus 1. X to the power of, and that take 1 from the power, get minus 3 over 2. So I know that at the stationary point, dy dx is equal to 0. So I can equate this to 0. So let me just rewrite this in the form 1 over 2x to the power of a half plus 1 over x to the power of 3 over 2. And let me equate it to 0. So what I can do now is I can multiply both sides by the LCM of the denominators, which is x to the power of 3 over 2. Now if I multiply the first term by x to the power of 3 over 2, I'll have minus x to the power of 3 over 2 over 2x to the power of a half plus x to the power of 3 over 2 divided by x to the power of 3 over 2 equals 0. Anything times 0 will be 0. So now I can just simplify this. I can simplify this. Let me just get rid of this thing down here. Make a bit of space. Okay, so I can simplify this a bit more. X to the power of 3 over 2 divided by x to the power of a half. I subtract the powers. That gives me x to the power of 2 over 2, which is x to the power of 1, which is x. So this is going to give me minus x over 2 plus 1 equals 0. This is going to be 1 because they cancel out. They're the same thing. And so I can say 1 is equal to x over 2. Therefore, x is equal to 2. That's the x coordinate of the stationary point. Remember, the equation of y is y equals 3 minus x to the power of a half, which is the square root of x. And you got minus 2 over x to the power of a half, which is the square root of x. So this is just written in a form it's easy for me to substitute in. This is like 2 over root x, and this is like root x. Okay, so I can say when x is equal to 2, y is equal to 3 minus the square root of 2 minus 2 over the square root of 2. Now they ask us to find the exact coordinates of the stationary point. So I've got to give this an exact form. So I need to try to simplify this. What I'll do is I'll put them all under the same denominator of root 2. So I have to multiply this fraction by root 2 over root 2. And I have to also multiply this fraction by root 2 over root 2. So I'll have root 2 times root 2 over root 2. And this one stays as it is. So this gives me, under the same denominator, root 2, I'll have 3 root 2 minus 2 times root 2 is 2, minus 2. Okay. Yep. So that gives me basically, let me just make some more space again. I can do this on the next page if I have to. That gives me y equals, this is going to be 3 minus 4, 3 root 2 minus 4. 3 root 2 minus 4 over root 2. Now I should really rationalize my denominator by multiplying both the numerator and the denominator by what will get rid of the denominator as an irrational number. So I multiply both top and bottom by root 2. So I'll have 3 root 2 times 2. That's going to be 3 times 2 minus 4 root 2 over root 2 times root 2, which is 2. So this gives me 6 minus 4 root 2 over 2. Both of those are divisible by 2, so I'm left with 3 minus 2 root 2. So the coordinates of my stationary point, okay, which I will just write down here now, are x equals 2 and y equals 3 minus 2 root 2. That's in exact form. Okay, so that's the answer to part B. I'll do part C on the next page. Okay, next we are asked to find the nature of the stationary point, whether it's a maximum or a minimum. So what we can do is we can find the second differential to do that. So d squared y over dx squared. This tells us the rate of change of the gradient, how the gradient is changing. Is the gradient increasing or is the gradient decreasing? If the gradient is increasing, that means it's getting less and less negative, and then it becomes 0, then it becomes positive. This is an increasing gradient. So that's a minimum, is when the gradient is increasing. The gradient is getting from negative towards positive, so that will give us a minimum point. So when the second differential is greater than 0, we'll get a minimum point because the gradient is increasing. It's going from negative to positive. Okay, but when the rate of change of the gradient is going to be less than 0, d squared y over dx squared is less than 0. When the gradient is going from positive to negative, so the gradient is decreasing, so the rate of change of the gradient is less than 0, then that means it is going to be a maximum. Okay, so when d squared y dx squared is greater than 0, you have a minimum. When d squared y over dx squared is less than 0, you have a maximum. So we've got to find what d squared y dx squared is first. Means we have to differentiate the gradient function another time. So it's minus a half times minus half, which is positive a quarter, x to the power of minus 3 over 2, and you're going to have minus 3 over 2 x to the power of minus 5 over 2. Take away a half from minus 3 over 2, get minus 5 over 2. I'm going to write this in a form which is easier for me to substitute values in. This is 1 over 4 times the square root of x cubed. This is the root and this is the power, minus 3 over 2 times the square root of x to the power of 5. That's my second differential, and I've got to find what happens when I put x equals 2 in here and see what happens to the value of the second differential. And you can see what happens here. You have 1 over 4 times the square root of 2 cubed, so it's a square root of 8, minus 3 over 2 times the square root of 2 to the power of 5, which is 32. Okay, so I can find out what this value is, if it's positive or negative. I mean, I can quite easily do this as 1 over, this is 4. Now the square root of 8, is like 2 root 2, because it's 4. So there's a 4 times 2, so it's 2 root 2. So this would be 4 times 2 root 2 minus 3 over, and this is like the square root of 32 is like the square root of 16 times 2, so it's 4 root 2. So this is 2 times 4 root 2. So you end up with 1 over 8 root 2 minus 3 over 8 root 2, and we can see that this is negative. This is negative. If you find the value of this, it's going to be negative, okay, because 3 over 8 root 2 is bigger than 1 over 8 root 2. Therefore, that will give you a negative value. So it's negative. Therefore, we're going to have a maximum. Okay, it's a maximum point. Okay, because as d squared y over dx squared is less than 0. Okay, so we know for sure it's a maximum point. Okay, the next part of the question tells us to sketch the curve. Okay, so I'm going to do that in the next page. Okay, so we have the information about the curve that we know that it crosses the x-axis at 2, 0 and 1, 0. It has a stationary point at 2, 3 minus 2 root 2, and also the value of x for this curve must always be greater than 0 as stated. Okay, so let me just see this is what we know that. Let me just take this over across there so that we can see it clearly. Okay, so let me take that across to where we need it. See the equation that we're actually plotting or sketching, not plotting. Okay, so there's the equation that we're plotting, and we can see here that x must be greater than 0. So basically we're going to have a pair of axes. We don't really care for the negative x side, we just care for the positive x side. Okay, so it's going to be something like this, and we know that it crosses the x-axis at 1, 0 and 2, 0, and the stationary point which is a maximum, is 2 and 3. Sorry, it crosses the x-axis at 4. Sorry about that. I think I made a mistake there. Yes, sorry, it was 4, 0 and 1, 0. Excuse me, it's 4, 0 and 1, 0. It's because it can't be 2, 0, can it? Because that was the value of u, not the value of x. That was a mistake from taking it from the other page. So I'll just, excuse me for that. So that's 4, 0 and 1, 0. So that's where it crosses the x-axis at 4, 0 and 1, 0. And the turning point is somewhere between them, 2. And 3 minus 2 root 2, okay, let's see where that is. Is that going to be, it must be above this. Okay, it must be positive. Let's just make sure. 3 minus 2 root 2 gives us, yes, it's a positive value just about. So it's somewhere up here. It's going to go like this. It's going to curve up. It's going to turn at this point here. And it's going to go like this. It's going to turn closer. This is 2. So it's going to be a bit closer to here. So it's like a bit lopsided like this. It's going to go through 4. Something like that. Okay. The turning point is going to be at 2. So let me just fiddle this a little bit. Put it so it looks exactly at the turning point, where the gradient of 0 is at 2. Closer to 1 than 4. Something like that. And that's fine as a sketch for our graph. You don't have to have anything more elaborate than that. You could write down here 2 and 3 minus 2 root 2 as the point, the stationary point, which is about here. Okay, so there's the sketch for the curve C. That's about as much as you need to detail you need to go into. And there we have it, the answer to this question. We have other questions from this Solomon L paper will be found in the playlist over here. So the P2 Solomon L collection, you'll find other questions once I've got around to doing them in this playlist. You'll have other questions from this end of topic worksheet on differentiation that have been asked about, will be in this playlist that should appear in this area here. Questions about differentiating in general will also be appearing in this. So like a question just about differentiation from P2 will also appear somewhere here. You'll be able to subscribe to my channel by clicking on this link, and I'll take you to a P2 past paper, full past paper answered. If you click on the card that you should have seen from the beginning of the video. Thank you for watching and see you soon.